Welcome to the BHT Machine Channel. Today, we will explore the process of manufacturing car tires, from raw materials to finished products. We'll learn how experts create durable and safe tires for vehicles. Additionally, we'll dive into the technology of retreading old car tires, helping to save costs and protect the environment. Stay tuned to discover the important steps and modern technologies used in both processes. At first glance, a tire may seem like a simple round and black object. However, beneath its simple exterior lies a complex and highly sophisticated product. The tire manufacturing process starts with a wide range of materials. These include natural and synthetic rubbers, carbon black, silica, sulfur, plasticizers, and vulcanizing agents. In addition, cords made of steel or fabrics like polyester and Kevlar play a vital role. Each material adds specific properties to the tire, such as elasticity, wear resistance, adhesion, and durability. The tire building phase is a crucial step in the manufacturing process, as it directly affects the tire's durability and load-bearing capacity. Outer rubber layer. This is the outermost layer of the tire, designed to protect it from wear and environmental impacts. The outer rubber needs to be highly durable and resistant to abrasion. Steel and fabric layers. Steel is used to reinforce the tire's structure, allowing it to bear very heavy loads. The fabric layer enhances the tire's flexibility and improves stability during movement. Inner rubber layer. This layer is typically designed to maintain consistent air pressure within the tire and helps protect the inner layers from external damage. One of the unique features of Giant tires is their steel and fabric reinforced structure. The steel wires are wound and arranged in fabric layers to form a strong framework that allows the tire to withstand heavy loads without deforming or breaking. The fabric layer enhances the tire's flexibility and load-bearing capacity, while the steel layer provides the necessary rigidity and stability. This steel and fabric structure is the reason why these tires can operate in harsh terrains such as quarries, construction sites, or outdoor environments. Without the steel and fabric layers, the tire would not be able to withstand such high impact forces. The prepared material layers are then fed into an automated assembly machine. This process involves stacking the material layers one by one. First, the inner rubber layer is placed into the mold. Next, the steel and fabric layers are stacked on top of the rubber, forming a sturdy structure. Finally, the outer rubber layer is placed on top to shape the tire. This assembly process requires a high level of precision, as any mistakes in layering could affect the quality of the finished tire. Automation technology enhances accuracy and minimizes errors during the assembly process. Once the material layers are fully assembled, the tire is completed by shaping and compressing the layers together. This process is performed in a special mold with precise temperature control to ensure that all the layers bond firmly together. This is a crucial stage to shape the tire to the correct size and standard shape. Compressing the material layers in the mold helps create a final product that is uniform and strong. To achieve high quality, this process requires continuous monitoring and adjustments, from mold temperature to compression time. This ensures the tire has optimal durability and meets stringent performance and safety requirements. A tire retreading plant is a cost-effective way to extend the lifespan of tires, especially large tires used in trucks, buses, and industrial machinery. To begin the recycling process, the old tire is brought into the plant and undergoes a thorough inspection. Technicians will check the tire for any cuts, dents, or damage. If the tire is still in good condition, it will be cleaned to remove dirt, grease, and other impurities. This cleaning process is crucial as it ensures that the new rubber layers adhere firmly to the tire's surface. After the tire is cleaned, the next step is to prepare the tire for recycling. The old rubber layers on the tire's surface are removed. Technicians carefully inspect the interior of the tire, ensuring that the tire's casing, the structural part of the tire, is still intact and undamaged. The casing will serve as the foundation for the new rubber layers. Once the tire is cleaned, the next step is to prepare it for the recycling process. First, technicians use a specialized grinding machine to roughen the surface of the tire. This grinding process creates a textured and clean surface, which allows the new rubber layer to adhere firmly to the old tire. This step is crucial to ensure a strong bond between the new rubber and the tire's casing. Next, technicians will inspect the tire's surface once again to check for any damage, such as cuts, dents, or significant defects. These areas will be ground down or repaired by removing the damaged rubber. Eliminating these damaged sections ensures that only the parts of the tire in good condition are recycled, allowing the tire to function properly and safely after being retreaded. Next, a new rubber layer is created and applied to the surface of the old tire. This rubber layer is designed to withstand friction, abrasion, and high temperatures, while ensuring the durability and flexibility required for the tire to perform in harsh environments. The new rubber layer is shaped and evenly applied around the tire casing, covering the entire surface. This process requires high precision to ensure that the new rubber adheres tightly and evenly to the tire, with no inconsistencies in the material distribution. This helps enhance the tire's durability, performance, and lifespan, providing optimal safety for users. Once the new rubber layer has been applied, the tire is placed into a mold and undergoes a vulcanization process. This process involves applying high temperature and pressure to ensure that the new rubber bonds tightly and hardens. The vulcanization process is a crucial factor in making the tire highly durable and able to withstand harsh conditions during use. Once the tire has been fully vulcanized, it undergoes a thorough inspection to ensure quality. Technicians check factors such as size, rubber flexibility, and the uniformity of the new rubber layer. Additionally, the tire must undergo tests for durability and load-bearing capacity to ensure it can perform effectively and safely.